Hello, so today we are going to go over how to solve quadratic equations using square roots. So to solve a quadratic equation using square roots, isolate the variable. Excuse me, I'm yawning. You can see it's early in the morning. All right. So to solve a quadratic equation using square roots, isolate the variable and take the square root of both sides of the equation. So if we're looking at this problem here. The variable is already by itself in this problem. The x squared is already by itself. So what we do is we take the square root of both sides. The reason that we do that is a square root, if you recall, the square root of x squared is equal to just x, right? So that gets the x by itself. It undoes the square. And a big rule in math is if you add in the square root symbol. So do you see how the square root symbol was not here to begin with? I added it in. You have to add in a plus minus sign. All right. So I get that x is equal to plus minus the square root of 25. And then the square root of 25 is 5. So there's two solutions here. X can be 5 or x can be negative 5. All right. And the reason you end up having two solutions is because 5 squared gives me 25, but negative 5 squared also gives me 25, because negative 5 times negative 5 gives me a positive 25. All right. All right. So this problem is a little bit more complicated, but we can totally handle it. What we have to do here is work to get the x squared by itself. In this first problem, the x squared was already by itself. Here, we have to work to get this guy by himself first. So think about just like if the problem was 5x minus 8 equals 12, and I told you to get the x by itself, right? You would add 8 to both sides, so we get 5x equals 20, and then you would divide both sides by 5, and we get that x equals 4. Okay, so that's exactly what's happening here, except for there's just a square on the x squared. So we add 8 to both sides. We get our 5x squared equals 20. We divide both sides by 5. We get x squared equals 4. Now, this is the new part. To get the x squared to become just an x, we have to take the square root of both sides. When you take the square root of both sides, you have to add in a plus minus in front of the square root. All right, so don't forget to add in that plus minus. Oops, I guess it looks like that. So we end up with x is equal to positive 2 and negative 2. All right. Now, here, all right, if we do minus 9, we get 2x squared equals negative 8. We divide by 2, we get x squared equals negative 4. And then we do our plus minus thing. We take the square root of both sides, but we run into a problem here. All right. We cannot take the square root of a negative number. Okay. So instead of saying no solution, I want to say no real solution here. All right. And this guy is not going to have an actual real solution because we cannot take the square root of a negative number. All right, so let's try this one. Here, the x squared is already by itself. So all we have to do is take the square root of both sides, and when you add in the square root symbol, you have to add in a plus minus. So we get x equals plus minus 7. So you can say like x is 7 and x is negative 7. So those are our two solutions. All right, here, again, my x squared is already by itself. I can take the square root of both sides. I get that x squared, I get that x is equal to plus minus the square root of negative 121. Now, I've got a negative inside of the radical. This guy has no real solution. All right, and then here, again, the x squared is by itself, I'm just going to take the square root of both sides, add in a plus minus, and I get that x equals plus or minus 13. And of course, you can split that into two solutions if you want. Whichever answer you like better, go for it. All right, so let's try this one. The x squared is already by itself. So I have to go ahead and take the square root of both sides. And when I add in the square root symbol, I have to add in a plus minus. So go ahead and simplify this. What would the answer to this be? So because we have a negative in the square root, this is going to be no real solution. All right? Okay, so now if we look here, the variable is not by itself right at the beginning. So the first thing we have to do is get the x squared by itself. So we're going to go ahead and divide both sides by 7. So we end up with x squared equals, and 112 divided by 7 gives me 16. All right. So go ahead now and finish solving this. So we can take the square root of both sides. When you add in the square root symbol, you have to add in the plus minus, and we get that x equals plus minus 4. All right, here. What would be the first step here to try and get the x squared by itself? We would have to go and divide both sides by -3. So we get that x squared equals 8. Now, to get the x squared to become just an x, I'm going to take the square root of both sides, add in a plus minus. So I get that x is equal to plus minus the square root of 8. Now, the square root of 8 is not a super nice number, but we do know how to break this down. So we would use our list of perfect squares, and we can break 8 down into 4 times 2. We can take the square root of 4, and we get a 2. So we do x equals plus minus 2 root 2. All right. So this one, there's kind of two ways to think about this. All right. If we're trying to get the x squared by itself, all right, one way to think about this, since you have a calculator, is to just divide by -1/2. So if you go on your calculator and do -36 divided by, and remember, when you put fractions into your calculator, put parentheses around the fraction. So I'm going to do -1/2 like that, and I get 72. All right, so I get x squared is equal to 72. Now that's one way to solve this. Another way that I think I want to make sure I point out to you is to multiply both sides by the reciprocal. So that's where you take the fraction and flip it. All right, and the reason that works is when I do -1/2 times -2 divided by 1, I get 1 out. It makes them like cancel each other out. All right, and then of course what you do to one side you have to do to the other. Oh, this is a -36. So again, we would end up with x squared equals, and then I would do my -36 times -2 over 1, and I get 72. So whichever way you like better, feel free to use. But from here, it's going to be the same way to solve, no matter which way you isolated the x squared. So go ahead and solve this. We're going to take the square root of both sides and add in a plus minus. We get x equals plus minus the square root of 72. All right. So we know how to break this down. Right? How do we break down square root of 72? Well, we use our list of perfect squares. It's 32 times 2. 36, sorry. And we end up with plus minus 6 root 2. All right. So here for number 4, again, we have to work to get the x squared by itself. If you recall, the first problems we did, the x squared was already by itself. So that's why we were able to go straight to just taking the square root of both sides and adding in the plus minus. Now here, the x squared is not by itself yet, so we have to work to get it by itself. So we're going to go ahead and, add 5 to both sides. So I get 3x squared is equal to 27. And then I'm going to divide both sides by 3, and I get that x squared is equal to 9. So what would my solution be here? Well, to finish it off, I just need to take the square root of both sides, add in plus minus, and I get that x is plus minus 3. All right. So let's give this one a shot. Again, we have to first isolate the x squared. So we're going to add 19 to both sides. And I get that negative 5x squared is equal to 163. Divide both sides by negative 5, and I get that x squared is equal to 163 divided by negative 5. Now, here's the deal. At this point, we could turn this, maybe try and turn this into a decimal, take the square root of both sides, but no matter what I do, this is a negative number. And if I were to take the square root of it, I end up with a negative inside of the radical, so we have no real solution here.